Good morning. Now we will see how the different pressure vessel standards and the different material standards have an influence on the dimensions and weights of a pressure vessel. Let's take just a very simple example. This is not exactly a pressure vessel. This is just the cylindrical shell of a pressure vessel. And now let's see how this has been designed. Let's see item, properties. Which are the properties? Item name, R001, pressure vessel standard, ASME VIII Division 1 edition 2021. This is the metric edition, therefore the units are megapascal, degrees centigrade. The set of materials, well, in this case there is a single material, a plate material, is in any case carbon, carbon manganese or carbon manganese silicium. Geometry, well, geometry is clear, it's a cylindrical shell. Let's see just the design conditions. The design condition is internal pressure, design temperature 150 degrees, internal pressure 1.5 megapascal, that means 15 bar. No external pressure, joint efficiency 0.85, corrosion allowance 1 millimeter. So that's we wanted to see. Now let's see the calculation, how this calculation has been made. Here there is a summary of everything that we have already seen. So the design conditions. The geometry is length 6 meters, diameter 1.5 meters, thickness 11 millimeter, and let's see a preliminary report according to the calculation code ASME VIII Division 1. The minimum thickness is 10.68 millimeter, therefore we have used 11 millimeter. Okay, well, we just want to see the dimensions we have seen. Now we see the weight, item properties. The weight of this vessel is 2,429 kilograms. Let's take a small Excel sheet, make it a little bit smaller, in which we have considered different pressure vessel standard, different materials, and we mark here the thickness of the cylindrical shell, which is 11 millimeter, and the weight, which is 2,429 kilograms. Okay, we'll leave this open. And now we close this, we go to another close item, and we take another vessel, or better, just another cylindrical shell, R002. It is just the same as the previous one. Let's see the properties. The difference consists in the item properties. The standard, it is ASME VIII Division 2, edition 2021, and class 2. This is important because you have seen that there is a difference in allowable stresses between class 1 and class 2. The design conditions are exactly the same, so we just look at the geometry, just to check that the geometry is the same. 6 meter is the length, 1.5 meter is the diameter. The thickness is a little bit smaller, is 10 millimeter. Why? Let's give a look to the preliminary report. The preliminary report tells us that the minimum required thickness is 9.66 millimeter. Just a small remark, among the different characteristics general here you have the under tolerance. I forgot to underline this when making the previous example. The under tolerance is 0. Why? The under tolerance is 0 because the material used, which is SA 51670, as in the previous case, has a tolerance of 0.25 millimeters. So the ASME code, either division 1 or division 2, says that if the tolerance is smaller than the greater between 0.3 millimeter and 6% of the thickness, you have the right to forget the tolerance. That's why we have used the 0. Note that this is not the same with the European standards. Okay, just let's give a look to the weight of the item properties. Of course, the weight is a little bit smaller, 2,206. We add 2,206. The thickness is less, 10 millimeter. Okay, well, we leave this open here. Now we close this item and we open another item, R003, this one. It's always a cylindrical shell. If you want to see the item properties, we see that the calculation code is EN 13445 edition 2021. Materials are always carbon steel materials. Design conditions always the same, 150 degrees, 1.5 megapascal design pressure, 0.85 joint efficiency, corrosion allowance 1 millimeter. We just give a look to the geometry, 6 meter, like in the other case. This time we have 8 millimeter and 1.5 meter diameter. Note that the material is not the same as before, but it is an equivalent carbon steel material. Instead of a 516 grade 70, we have used a P355GH EN 10028 part 2, thickness less than 16 millimeter. And in fact, from the preliminary report, we see that the minimum required thickness is 7.98. That means that we can reduce the thickness to 8 millimeter only. You have seen here 8 millimeter. So, okay, just take a look at give a look to the weight, item properties, 1,786. So we update our Excel sheet, 8 millimeter, 1,786. Okay, we leave this open, close this item, Let's give a look to some other standard. We take this R004. This has been designed according to the Italian standard VSR. We open the item just to check that the properties are exactly the same. Item properties. Design conditions, 150 degrees, 15 bar pressure, 0.85 welding efficiency, 1 millimeter corrosion allowance. Then we close this. Let's look at the calculation of this. Geometry is exactly the same. Tolerance has been considered, 0.3, because according to the Italian code this has to be considered. Let's look at the preliminary report. The preliminary report, again, 7.98. So because the formula of VSR is exactly the same formula of EN 13445. Let's close this and look at the item properties. The weight is exactly the same as before because there was no change in thickness. Let's update our Excel sheet, so it's still 8 millimeter, and the weight is always 1786 kilograms. Well, let's close this item and open another one, which is R005. Okay, this one. This is the same, always the same cylindrical shell, but this time the cylindrical shell is calculated according to the German pressure vessel code AD 2000. Item properties, AD 2000, design conditions are always the same, 150 degrees and 15 bar, 1 millimeter corrosion allowance, efficiency 0.85, and if we want to look this better, preliminary report is always the same dimension, 6 meters, 1.5 meter diameter. The tolerance has been considered because according to AD 2000 the tolerance has to be considered. The material is always the European material. With all the European standards we have used a European material, and the preliminary report says always 7.98. The formula is the same. Maybe the nominal design stress could have been different because in AD 2000 there is not the limitation as in EN 13445 of the tensile strength divided by 2.4, but at the temperature of 150 degrees this condition on the tensile strength is not controlling. That's the reason why the nominal design stress is the same, the formula is the same, and therefore, no doubt, then if we want to go to the item properties, that the weight is always the same. We take again our Excel sheet, the thickness is always 8 millimeter, and the weight is 1786 kilograms. We leave this open. We give a look now to another example. Let's close this close item and open another one, which is L006. You see that in this case, the calculation code is always ASME VIII Division 1, edition 2021. The component, the item properties are the same, but there is now a little difference. Design conditions are the same. The difference is the material, because you see that in the ASME database, or in the database of ASME VIII Division 1, there is also the EN material, however with the thickness lower than 60 millimeter. Let's look at better in the data in this database. You see SA EN 10028-2 P355 GH, but unfortunately, the conditions are only for thicknesses below 60 millimeter. There is nothing for thicknesses smaller than 60 millimeter. There is something for thicknesses higher than 60 millimeter, up to at least 250 millimeter, but with this condition, there is some doubt that we can have some advantage. In fact, no, the only advantage is that the under tolerance is 0, because according to the ASME code, the under tolerance is 0, because the plate tolerance of, according to EN, is 0.3 millimeters. It is always smaller or equal 0.3, therefore it has not to be considered. The preliminary report says that, okay, the minimum thickness is something less, but we have 10.14, we have always to use 11 millimeter. No real advantage. We accept this, and we give a look to the item properties. The item properties 2428. 2428, we update our small Excel sheet, 11 millimeter, 2429, sorry. We close the item, and we must try to use also with ASME VIII Division 2 any N material. We take this further item, R007. Look at the item properties. ASME VIII Division 2 Edition 21. The design conditions are always the same, 150 and degrees centigrade 15 bar. And you see that in this case we have the EN material, but in the Division 2 database, we have a small surprise, that the fact that, contrary from what was provided for Division 1, for Division 2, there are the various classes of thickness. So not only smaller than 60, but also between 60 and 40, and also smaller than 60. Well, in this case, you can see that we have an advantage, because if we take the preliminary report, you see that now we have used 8 millimeter, because the required thickness is 7.37 millimeter. Note that the under tolerance is 0, because according to ASME VIII Division 2, the 0.3 millimeter, which is the tolerance of the EN material, has not to be considered. So we can close the calculation sheet, and now, okay, there is not necessarily necessary to check the weight, because we know already what is the weight of this shell when its thickness is 8 millimeters. It's 8 here, and here again 1786. Now, there is still one test that we have to make. We close the item, and we open another item, which is R008, which is always the same vessel, or better, it's always the same shell, but the same shell with now a change of material. Look at the item properties. Item properties. Here you see the design standard is EN 13445, issue 1, edition 21, but now the design conditions are always the same. If we look at the calculation of this shell, we see that now, despite of the fact that the code is it's the European harmonized standard, we have still an ASME material with a small note. The note says that PMA is necessary, a particular material appraisal. If you have understood the lesson of this morning, this is always necessary when you use the ASME materials with the European standards, or better, with the Pressure Equipment Directive, because the Pressure Equipment Directive always requires the guarantee of the material manufacturer. The guarantee of the material manufacturer is not in the design, in the specified standard, because the ASME standard only contains room temperature properties, and the hot yield properties are in the ASME code, but they are not guaranteed. It is necessary, therefore, to make an order to a manufacturer specifying the ASME standard with an additional requirement. The additional requirement is the guarantee of the hot yield strength at the design temperature. Well, let's check what happens here using the ASME standard with the harmonized pressure vessel standard. Minimum required thickness 9.87. Look here, we have considered the under tolerance, because the under tolerance, according to the EN standard, has to be considered. There is a yellow warning. Let's just check what is this warning. Selected material belongs to material group 11.1. This note simply says that if the carbon content of the material is at the upper limit provided by the ASME specification, the consequence is that the class of material is not the normal carbon steel, it becomes a very special class. Certainly, in this case, if we buy the steel in Europe, but I think that also if we buy it somewhere else, the carbon content is well below the maximum limit provided by the ASME material. This note is not interesting for us. What is interesting is the fact that now we have a thickness of 10 millimeter. Going to the item properties, we see that the weight is 2,206 kilograms, and we can update, therefore, our small Excel sheet. So with 10 millimeter, we have already the case, 10, with a weight 2,206. Well, if we give a look now to all these possible cases of a vessel, or better, it's only a cylindrical shell, of course, the results may be different if we consider the entire vessel, but certainly the cylindrical shell is, for a vessel like this, supposing that also you have two ends here, two domed ends, but at the end, the weight is influenced mainly by the cylindrical shell. Well, you see that according to the material you use and the standard you use, you may have difference from 1700 to 2400 kilograms. That means almost 40% in respect of the lower values. Well, with this I have finished. Thank you very much for your attention.